You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening wherever you are. We're coming to you from Boston, Massachusetts. Today is April 2nd, 2024. Hope everyone is doing well and staying safe. Can you believe we're already in April, Bhavin?
I know. Q1 is done, at least for people that use calendar year and not fiscal year.
Yeah, are you CY or FY?
Yeah.
Those terms bothered me so much until I kind of got used to them. But
yeah,
just stick to one.
So first quarter is done. I'm not sure how you are doing on your goals, but
good for the most part.
Yeah, I am learning Japanese though, like through Duolingo. Like I'm planning a trip to Japan. Yeah, so I'm keeping that streak alive. You know, let's go.
Can you say something in Japanese yet?
Oh, dude, no, please.
Konnichiwa.
Yeah, konnichiwa. Let's go. Konnichiwa, Ryan-san.
Nice. No, that'll be a fun trip. I really want to get to sort of that part of the world. I was just talking to a buddy of mine. How we have in the next 3 years to try to travel to like Thailand and Vietnam. Just we've always wanted to, and he's a birder, so I don't know if you know, but Thailand has the most species of birds or whatever, like any country.
Nice.
Yeah, well, I know that because of him, right?
Okay.
There's no other reason for me to know that question. Yeah. I mean, we've had birders in our lives before, right? Our previous boss and stuff. So, hey, he's pretty pumped. I'm mostly going for like the landscape and the food.
And the food.
Yeah. But I haven't been to that part of the country, world at all, right? So it's always been sort of something I want to do. So that's exciting, man.
I'm definitely not a birder. You know how I know that?
Not a bird. I mean, they're great. I have nothing against birds.
Like the reason I know this is like we were in Patagonia and we were on a hike and Mansi was like, "Oh, that bird is awesome," and I just kept walking, dude. I didn't even stop to look at it.
Birds exist here.
Yeah.
What of it?
Okay, man. Yeah. I'm tired. I just want to finish this. I'm not looking up.
Did we ever talk about Patagonia on this trip?
No, I don't think we
do this
did
so often.
Yeah.
But besides the birds, because we know how you feel about them, how was it?
No, Patagonia was awesome, dude. I have some tips if you ever want to go to South America and not just Southeast Asia. Like the terrain is completely
I would love
different.
to travel more in general, but we'll see where I get to first.
No, Patagonia was super cool. I can't believe we haven't spoken about this.
Right? I don't know what happened. We blacked out last month.
Yeah. No, but it was supposedly like early summer, but it was still cold. Like I had my jacket on for all the hikes. We did as we had discussed before I went to the trip, right? We did Chile. We were planning on doing Chile and Argentina. We did both of those. We had some ups and downs because we were just planning the whole thing on our own and just renting out a car. There were some challenges there too. But the Chile part was really crowded and more touristy. I felt because it was like an official national park and there were like tours.
And it was their season to do that kind of thing. Yeah.
But the Argentina side, like I love the town that's near the Fitzroy Mountains. Like it's called El Chaltén, and dude, there are like 20 restaurants and just lodges or hostels or hotels, and that's it. Yeah. There's nothing else. So it's the perfect place to stay. Got some good pizza and good local food. But it was an awesome trip.
Traveling, you can learn so much just by the food, or even just the people. At these places with food.
Yeah, like in one of the restaurants, I know we're going down a rabbit hole, but
it's okay.
At one of the restaurants, I was sitting besides, like it was a communal table. So I was sitting with a guy from what's the country opposite Argentina? Come on.
You got me. I don't know much about that. Let me pull up a map.
Yeah, it starts with an okay, I need to pull that up too. Shit.
South American countries. here's the
Uruguay. Okay, I got
Oh,
it. So we had somebody from Uruguay, we had somebody from Chile, and we had somebody from Peru. Like those three were friends. I don't know if they knew each other before or they just met that week, but they were hanging out, having a good time. We were talking about like politics in different countries. Like Argentina was definitely going through the presidential elections and the change of power there. So it was a fun discussion, just meeting different people and looking at talking about different perspectives. Again, best part of travel, right? You get to meet people.
Oh, it absolutely does. Finding excuses to travel is always a good thing. So.
Yes. Okay, so since our KubeCon episode had all the news that we had to bring, I think this is going to be another no news episode.
Yeah, no, another not the news segment on Kubernetes Bytes. You only get two to four a year, around the KubeCon.
Yep. No, I think like post KubeCon vendors are done with all the marketing, right? Like nobody announces anything after KubeCon, like 2 weeks
it's
after.
Slower
KubeCon.
For sure. I mean, like news trickles out and things like that, but yeah.
Yep. So I'm ready to like get our guest on and talk about an interesting topic.
Yeah, we will link to that news episode. So if you're itching for news and you're crying a little bit because there is not the news segment, you can go and listen to that episode. But yeah, our guest today is Charlie Egan, who is a senior now developer advocate at Styra.
Yeah.
I forget which one.
I don't know. Styra, maybe?
Yeah, I'm sure he will tell us, right?
Yes.
And we're going to be talking about Open Policy Agent, OPA. And if you don't know what it is, good, because now you're going to find out with us, because we don't know a lot about it either. But it certainly is some pretty interesting pieces of content here. So without further ado, let's get Charlie on the show.
This episode is brought to you by our friends from Ilotel. Ilotel Luna is an intelligent Kubernetes cluster autoscaler that provisions just-in-time, right-sized, and cost-effective compute for your Kubernetes apps. The compute is scaled both up and down as your workloads demand change, thereby reducing operational complexity and preventing wasted spend. Luna is ideally suited for dynamic and bursty workloads such as dev test workloads, machine learning jobs, stream processing workloads, as well as workloads that need special resources such as GPUs or ARM-based instances. Luna is generally available on Amazon EKS, Google Cloud GKE, Azure AKS, and Oracle OKE. Learn more about Luna at ilotel.co/Luna and download their free trial at ilotel.co/Luna-free-trial.
All right, welcome to the show, Charlie. Welcome to Kubernetes Bytes. It's good to have you here. I'm excited to learn a lot today, but why don't you give yourself an introduction for our listeners and a little bit about what you do?
Okay, great. Yeah. Thanks for the invite and thanks for having me. My name's Charlie. I work on the developer relations team at Styra and with the Open project on the Open project. My focus really is around making OPA easier to learn and easier to use. I spend a lot of my time working with new users of the project, new maintainers or new contributors, people who are interested in doing their first open source contribution often, and also taking part in events and representing the Open project at various events. We've got KubeCon next week, so that's something that's coming up. So with those different things, I find plenty to do.
Gotcha. That's awesome. No, I think thank you for taking the time out, right? I know we're recording this pre-KubeCon, so appreciate that. And since we got connected, I saw you also got promoted. So congratulations, Charlie. Now you are, I guess, a senior developer advocate. So that's awesome.
Yes, that's right. Yeah, that's my title. Thanks very much, and very observant. Very observant of you.
Awesome. Okay, so let's start by talking about OPA, right? So OPA, or Open Policy Agent. I want to learn more about it, as Ryan said, right? This is going to be a learning experience for us. If you have listened to our previous podcast, we have done Kubernetes Security 101 episodes, and we have had vendors like Armosec and like Mondu talk about the scanning piece, once your workloads are already deployed on your Kubernetes cluster. I want to learn if you can give us a high level overview, and then we can dive deeper around what OPA is and how it helps improve security postures for an organization.
Sure. So OPA is a general purpose policy engine, and I suppose very very much part of OPA is the policy language, which is called Rego. So I think of OPA really as a whole as those things. So the language and a policy engine to evaluate policy in that language in the context of some data. There are lots of other parts to it, I suppose, as well. We have ways of integrating with OPA with various different languages. There's the community and the support and the ecosystem of tools built around OPA, some of which we'll touch on today. But at its core, OPA is a general purpose policy engine and policy language for making policy decisions. I think
Gotcha.
that's hopefully a good overview.
Yeah, no, that works for me. So can we talk more about some of the use cases, right? I know
Sure.
last time we spoke, we were talking about how it helps you do 2 or 3 different things instead of just one thing that relates to admission control.
Yeah, I suppose you're interested, around sort of security, how it helps people make their platforms and Kubernetes clusters more secure.
Absolutely. Yeah.
So or where it fits in that stack, is it a runtime security piece? Is it something that you run when you're building your applications and whatever? Yeah. So yeah, really, it's the most common use cases for us is authorization. That's mostly the use case that we tend to focus on, and a lot of the work that we do and the content we produce is with that as the focus. So anywhere that you are doing authorization is a kind of top tier use case for us. That would often be perhaps applications within your platform talking to each other, communicating with each other, sending each other messages, and whether those messages are allowed or not. And you can think of potentially different ways in which that might happen. So that might be happening in your service mesh, where it's an integration with the service mesh proxy, and the service mesh proxy is consulting OPA to make decisions around what messages between services can be sent. But it could also be the application itself is integrated with OPA and making calls to OPA using the REST API. It could be it's a API gateway or some other central piece of your infrastructure where policy decisions are being enforced for a whole range of applications, and so on. So I suppose those are the kind of application authorization use cases that are kind of the most sort of prominent for us. But there are sort of Kubernetes specific authorization or authorization-like things as well around who can deploy what into which namespaces, what operations can they perform on existing Kubernetes state, and Kubernetes provides, perhaps we can get into this in a bit more detail later, but sure. Good integrations to control what's going on within a cluster as well. So I'd say that those are, when I think about the use cases, that's probably where I would start. But we, like I said in my introduction, OPA is a general purpose policy engine, and you can use it for more than just authorization. You can use it anywhere. And I always, when I'm talking to people, as I'm expected to do lots of next week, I'm always encouraging people to think about they can often think of one use case, and that's why they've come to speak to you. But try and encourage people to think about the other use case, the other places they may be running policy. And particularly Kubernetes people are very familiar with this Kubernetes admission use case, but often because their team isn't responsible for it, maybe they don't really think so much about application authorization, or maybe because their team again isn't responsible for it, they're not thinking about the permissions on accessing data stores or controlling what happens in large monorepos or other infrastructure as code stacks that are unrelated from Kubernetes, perhaps. So really, we have a range of out of the box or kind of open source part of OPA Core integrations with different projects, but there's also the OPA ecosystem where there's a whole range of different things that people are building with OPA. So as I said, to summarize, authorization is our kind of tier one thing that we generally focus on and make sure we have a very good story for. But it is intended to be a very general purpose tool, and there for you to evaluate policy in a standard way in a whole range of different use cases.
Yeah, it makes sense. And I'm just looking at the some of the documentation, things like that in the background here. It was actually I didn't know how I felt about myself seeing so much YAML until I saw what the declarative policy, which looked like Python, and I was like, oh, that's That's actually quite nice. It's not just more YAML, I should say. So is this declarative policy mostly done in Python, or I guess it's
Rego, I guess.
Python?
I'm not sure exactly which page you're looking at, but Rego is the language. It looks a bit like various other languages, but it is its own language.
It is its own thing. Okay, it looks very much like Python. If I was,
Yeah, it takes. I suppose it's. It's most. I suppose like this. The syntax is evolving, but is mostly set now with Rego v1 and Opera v1 on the horizon. But when I first started using it, I always thought it looked quite like Ruby, but then the assignment operator is quite like Go. But it's, I suppose it's kind of most sort of natural ancestor or inspiration would be something like Datalog, depending on how you look at it, maybe SQL as a kind of query language. Like it, even though it maybe looks like an imperative language or looks like Python, I think when people start to use it, they often find it works very differently, and it does work very differently from an imperative language.
Got it. Okay, that explains a lot. Good to know. So I know it's a general purpose policy tool, and it works with more things than just Kubernetes, right? I see some WebAssembly stuff, some AWS CloudFormation stuff. But we're going to focus, a little more on the Kubernetes side of things. But maybe before we jump into, the integration and how it kind of works with Kubernetes, maybe talk a little bit about, where OPA sits in the various use cases. So if you're using with CloudFormation or if you're using it with that kind of, does it usually sit with the application? Like when you're writing policy, does it sit with the application, or is this more of like a sysadmin sort of tool?
No, it's a good question. Yeah. I suppose like the use case really defines where OPA is running.
Okay.
So when you let's imagine a few different use cases and think about where OPA runs. So you're building an application, and you want to run some policy over that application's dependencies, for example, which is something that people do with OPA. In that case, OPA is probably going to be available as a binary or running as a container stage within a build pipeline.
Okay.
So you would pull the OPA container or download the binary and run some OPA command based on some structured data about the application's dependencies, and fail the step if the policy violated.
Okay.
So that's one example. Another example would be the Kubernetes admission example. So you would run a deployment, replicated deployment of a number of OPA pods on a Kubernetes cluster. The control plane would have validating webhook configuration to point to the OPA service within that cluster. So the control plane would reach out and make, and OPA would respond with an admission review saying, is this resource allowed or denied? Yep. And so in that case, OPA is running very much like any other Kubernetes workload.
Okay.
Thinking about another use case would be like we have an integration with the Envoy proxy, where you can run an OPA sidecar adjacent to your Envoy sidecar alongside your application. Okay. And in that case, OPA is running in the sidecar model next to each application. And so, I suppose like there's three different use cases, three very different ways in which OPA is used and invoked, I suppose. And really, it's kind of like I suppose to think about one other use case, and you made a brief reference to the WebAssembly. WebAssembly way of building Rego and evaluating it as well. Like that was a feature that was added to OPA's capabilities in order to allow people to run OPA where you can't run normal binaries, or you don't have access to run containers and things. Examples being kind of CDN, so edge locations and things like that. So there with those four, there are others, but like that gives you a pretty good spectrum of like these are the different ways in which you you might run Opa. Hopefully that
very cool. And yeah, we'll put a link to I guess the ecosystem page or something, because there are a lot of integrations that I'm realizing now that it being general purpose, there might be a use case we don't cover here on this show. So if you're listening, we'll put that in the show notes where you can kind of learn a whole bunch more too. So let's double click on the Kubernetes integration, right? So with OPA and the emission control use case, how does that integration work? I think it's called Gatekeeper. Can you explain a little bit more about that project and kind of what the capability?
Sure. So Gatekeeper is a sub project within the wider Open Policy Agent project.
Okay.
And Gatekeeper is I suppose an extension on OPA for the Kubernetes validating admission, mutating admission use case very much specifically. And OPA Gatekeeper has been adopted by various cloud providers in their managed offerings to offer this functionality in a managed way, admission review and mutating functionality as part of the managed Kubernetes offering. But often people are running it themselves, and it works much the same way that as any service which backs a validating webhook configuration, in that you run a deployment of Gatekeeper, and it can respond to admission review requests typically as new things or changes are landing in the Kubernetes API. The Gatekeeper project have a few extensions, I suppose, that make it which people find valuable when using it with Kubernetes.
Sure.
One of the main things that people use Gatekeeper for is to allow them to define their policies in custom resources. So if you are one of those teams who define everything in Kubernetes state, you make heavy use of controllers and so on, Gatekeeper is quite a good fit. In particular, if your main policy use case is actually Kubernetes is only really Kubernetes admission, and you don't have an additional an additional sort of state store for your policy to hand, and you want to just make use of the Kubernetes API to store the policies. And so Gatekeeper is there for people in that use case. They also have a CLI tool to allow you to run the same policy against resources prior to deployment, so you can do a kind of pre-flight check. And Gatekeeper also maintain a library of policies for common use cases, common Kubernetes use cases. So, for example, there's like a pod security policy. When I started using Kubernetes, there was this pod security policy, I think, but now they have this implemented as admission control checks instead. So I'd say that those are there are a few other features that Gatekeeper has, but I think those are the kind of core things that people who are kind of working with OPA but exclusively in the Kubernetes admission use case, they're the thing that they find, those are the things they find useful.
So Charlie, I have like a basic question here. So Kubernetes out of the box has some sort of role-based access control, right? It does its own authentication and then authorization. So are there like additional features that a user would get by running OPA and Gatekeeper? I like the pre-flight check functionality, but like, are there more knobs that you can turn by running this project on your Kubernetes cluster than just relying on what comes out of the box?
Yeah, so I mean, this is just has been a moving target within Kubernetes for a while, and I suppose with the common expression language and integration of native policy functionality landing in the API server itself, like this continues to be something which is evolving. But I suppose the way that I started using OPA in this use case. I was working on a Kubernetes platform, and we had a requirement, which was that particular teams could only create internal load balancers or services with a particular cloud provider annotation that meant that their services load balancer would be provisioned as an internal load balancer rather than an external load balancer. Some teams were allowed to provision external ones, and some were allowed to only provision internal ones. And this is something that at the time you couldn't I think you could do this now with Cell in the API server, but at the time, this was an example of something which you couldn't do with the Kubernetes native permissions. And I think even though you can do that with Cell now, I think both OPA and OPA Gatekeeper have ways of gathering up other Kubernetes resources to allow you to make decisions based on the state of other resources. And that's, I think, something that you still can't do without an admission validating admission check. So, for example, another policy we had at the time when I was first working with OPA was around making sure that teams were using unique host names, so they couldn't create duplicates across different namespaces and clusters. So we would have all of the other ingress resources and the state of all of the other ingress resources loaded in to OPA, and then you could run a check and say okay, well, based on the existing ingress resources, is this name unique? And if it wasn't unique, then it would reject the request. So I think it's really and I guess with Cell now in the API server, it's increasingly a kind of break glass sort of, I have a business requirement for this particular policy, and I need something a little bit more custom. And I think that in particular is or at a high level, that's where OPA, but also any kind of custom validating admission tool fits in. Both OPA and Gatekeeper also have ways of bringing in external data in addition to external Kubernetes states. So I talked about bringing in the list of ingress resources, but you might want to also bring in data from another system. And OPA and to an extent Gatekeeper have a good ways to do this as well. Gotcha. So sometimes you might be basing it on permissions that are defined elsewhere or data which is defined elsewhere. So yeah, I think that makes that's sense. The main thing.
Gotcha. Thank you, Charlie. So since we were talking about authorization, right? That's great that OPA helps me authorize different aspects of my application stack. But as that sysadmin persona or the operator persona, can it also help me audit which parts of my applications were trying to do some things, or what requests got approved or reject? Is there a UI or a CRD based resource that I can query to look at what happened in my cluster?
Yeah, so good question. Auditing is a very important feature for us. It's a feature of Gatekeeper as well. It works slightly differently in OPA Core versus how it works in OPA Gatekeeper. Okay. Again, there are Styra's product has a UI. There is so to allow you to view auditing data about decisions that have been made. But just to roll back to what's going on there, when a resource arrives or when a decision authorization or any decision is made by OPA or Gatekeeper, there is a decision that's being made. And gotcha. In addition to responding to the caller, so just to bring in some terminology, there's a policy enforcement point and a policy decision point. Okay. So a policy enforcement point in Kubernetes is the API server, but it's a policy decision point is OPA or Gatekeeper or any validating admission integration. In the service mesh example, the policy enforcement point is the proxy. The policy decision point is the OPA sidecar running in the same pod, and that policy decision point, it responds to the policy enforcement point, but it also is able to log in various different ways a decision that's been made. So OPA produces these batched decision logs, which it can send to an HTTP endpoint. It just so happens that the Styra product has a way of gathering these up and displaying them in the UI. For Gatekeeper, it works slightly differently. They send audit data to a PubSub PubSub sync that you can configure. I think they also support some way of storing recent audits or recent decisions in Kubernetes state as well. And at least they used to do that.
I know you said.
But the PubSub is their kind of, I think, the main way that they encourage people to look at audit data now in Gatekeeper.
Okay. So HTTP and PubSub, is there any way to feed all of this into Prometheus and Grafana, or this is not really it's not generating metrics information, right? That or a time series based information.
Yeah, so you could see OPA does expose Prometheus metrics and things, but I suppose the information that I suppose Grafana these days includes log-based metrics, but typically, I suppose in the way that my slightly outdated thinking on the matter goes is like in that decision log entry, it's to me very important that the decision log entry contains enough information in order for you to replay the decision. So what you need to do that is you need to know what the message that came in was and what the policy version and data version was at that time. And then you need to log all of that information so that 3 months, a year down the line, you're asked to say, why was this allowed? You can go and get the policy at that version. You can go and, you've got the information that was provided to the policy decision point in your log, and you can then say, okay, well, it happened for this reason. Either there was a bug in the policy, or some of the permissions hadn't been updated in the permission store yet, and so on. And I think like you can get like performance metrics and stuff out of OPA about like what's your query decision time and this kind of stuff, which is operationally important data. But when it comes to the same for Gatekeeper, when it comes for the decision log data, like I think the use case is slightly different. The use case is around responding to like an auditing type challenge or a security incident type challenge, and the information that you have there is structured, I suppose, or kind of there for a different purpose, maybe as I see it.
Gotcha. Okay, thank you.
Yeah, and I imagine, while you guys are talking, I'm imagining this use case where like you would have some policy that says, you can't pull from, some registries that aren't in these pool of registries, or they must have a certain label or that kind of thing.
Yeah.
I imagine that historical data could be something you could look back at or even monitor, right? To say if all of a sudden we're seeing a lot of violations of this policy, right? That could be something sort of, that a team could look at or even have in sort of historical data to kind of evaluate for whatever reason, right?
Yeah, you could do all sorts of analysis on the decision log data. In the Styra product, there's a kind of representation of different response codes and things presented, but people could access the raw data, and as you say, could do whatever kind of after the fact analysis you were interested in.
Sure. All right, so I'm going to switch gears a little bit and talk to you about sort of service meshes. I can speak today. I didn't do my vocal warm-ups. So OPA is or isn't a replacement for a service mesh, or where does it sort of fit into the way service meshes work? Because we often hear about these tools, service meshes in general, also having sort of policy between microservices and things like that. So explain a little bit of the difference or similarities, if there are any.
Yeah, sure. So OPA is not a replacement for a service mesh. You might find some of the policy functionality of that any given service mesh provides could be replaced by OPA if you wanted to. But there are additional features of the service mesh which OPA has doesn't solve or has no intention of solving.
Right.
Like I suppose one of the main features of a service mesh is providing service identity, which is that's a kind of like infrastructural service provided to tenants of a platform to enable service-to-service authentication. And so like that's, I suppose, two definite things that OPA is not doing. OPA is not provisioning identities, and it is not authenticating workloads or users. It is you can write policy to authorize requests from services, from users, based on the identities that they have, which may or may not come from the service mesh. But it's fundamentally not providing identities and not authenticating users and services. Gotcha. So I think, like, at a high level, that's how I think about it. They are different things. The Venn diagram overlap is where, as you were right to highlight, like, service meshes have some amount of policy functionality, similar to the Kubernetes admission use case, where the Kubernetes API server has some policy functionality. OPA overlaps with that part, but only that part. Like, it's not a cluster administration, etc. tool. So yeah, like, people use OPA alongside service meshes. A common way that people do this is we have, for Envoy service meshes in particular, we have the OPA Envoy flavor of OPA, which is built and released in cadence with the OPA releases. Envoy has an API called the External Authorization API, which is a gRPC API, which is not supported in the sort of mainline OPA container or OPA distribution, but the OPA Envoy proxy implements this API. It's also implemented by Styra's enterprise policy engine, but this gRPC API allows the Envoy proxy to send information about the request it's received, where it's come from, and headers, and so on. And you can run policy over it, and it expects, similar to the Kubernetes admission review, it expects a particular response back to the proxy, and the proxy will respond accordingly, or add headers, remove headers accordingly. There are various different operations you can do. So I suppose, like, OPA allows you to extend the policy controls of your mesh. So yeah, like that. I think that's how I think about it.
Yeah, that makes a lot of sense. One thing I was sort of thinking about while you were talking about this, right? Meshes typically add sidecars, and they enforce things like that. And then you have this other container, which is essentially what OPA's doing, and kind of, I guess, Envoy could get something and then, basically consult OPA to make sure things are, enforced in that policy, and then kind of comes back. That, does the concept of sort of bloat ever come up, or like, what's the performance of, like, adding these layers? It's a question we hear often, especially talking about meshes. So I'm curious of, if you get that question as well in the
it's a very valid question. I think, so people have been talking about bloat since we first started talking about sidecar based service meshes for as long as service meshes have been around, right? So the OPA container isn't for small amounts of data. If you load loads and loads of data into OPA, surprise, it consumes more data in memory. But if you aren't doing that, it's not it's not a particularly heavyweight workload to run alongside all of your application instances. So for certain types of policy use cases, that's totally fine if you're not using lots and lots of data. However, if you are using lots and lots of data, you can imagine how if you had each OPA was consuming a gigabyte in memory, and you were running this for every single instance, it would be quite expensive when it came down to it, in terms of the resources that were provisioned just to run sidecar containers. So this was, I suppose, like OPA, we always thought about OPA running close to the application so that you can have quick response times. But as that use case where you have lots and lots of data is one of the main reasons that, or one of the ideas for a different deployment pattern that we had with Enterprise OPA, where you would run a larger, well-provisioned, replicated service separately in a quick enough or a low latency enough area of the platform that would allow you to have larger amounts of data loaded in that you would call to centrally from. And you could run OPA in the same way. It just so happens that Enterprise OPA has some ways of more efficiently working with very large data sets. But that deployment model isn't invalid. I suppose what I would encourage people to do is, as with all good engineering problems, it's a trade-off. What do you care the most about? What is most important? Is it that you are able to make authorization, or is it that you're able to make policy decisions over a large data set, and you're willing for it to be a little bit slower? Or would you rather have it such that you have many policy engines very close to your applications in order to make very quick policy decisions for those applications?
I think trade-off is the key term there, right? I mean, there's no one size fits all. There's no one answer. It really depends on the use case. And again, like what you were saying, like if you have security components and mesh components and OPA in there, well, you might be trading off on the fact that things are enforced and they're secure and all these things. And you might spend a little bit more money, right? But I think at
it's
the end
worth
of the
it,
day,
right? If it's secure,
that might be an okay thing.
Yeah. So Charlie, like I know you were talking about like OPA running as a sidecar container and then working with Envoy proxy. At least in the service mesh ecosystem, right? We see a transition or at least a push towards more of that ambient mesh capabilities where you don't have to run these sidecars.
Mm-hmm.
Is OPA going to have like a similar solution where instead of relying on sidecars, there's like a centralized component that does all the policy requests? And just curious to know if that's the direction that we are headed into.
Yeah, so I suppose in this in this use case, OPA, if you wanted to use an ambient mesh and you still wanted to get low latency policy decisions, the way to do that would potentially be to run OPA as an instance on each node. You could continue to run it as a sidecar. And it would again be up to you really as to like what you wanted. So there is some simplicity in running it as a sidecar still, but you might want to also manage it as a kind of cluster service where there is a local instance for applications on that node to speak to and so on. Like OPA isn't going to get bundled any lower in the stack. So like if you want OPA functionality, you're still going to need to run OPA somewhere. So like I suppose in the same way that you still need to run your service mesh components and on the nodes as well. You're maybe not running sidecars anymore, but so you've still got to run OPA somewhere. So if you want OPA, if you want the fastest possible response times from OPA, you're still going to need to run OPA on the node somewhere, either as a separate deployment or set running on that node, or as a sidecar. So yeah, like I think it's just comes back to what people want to do again.
Yeah, the possibilities are there. Like the deployment modes are supported. It's just like best practice versus something that's special for a specific use case.
Yeah, but it's I mean I feel like this is quite an evolving area, and it's kind of TBD as to what the patterns will be, but there are some things that if you're interested in using OPA to standardize how you run policy across a whole platform, like you can't get away from running OPA somewhere and so on. So but I can imagine people switching up how they run OPA as sidecars become potentially even less trendy. It might be that people start to run them in other ways.
Cool. Well, I know this is like my favorite term so far. I'm going to switch gears again a little bit. Something Bhavin and I have often heard from our guests is more and more teams are but are getting into multi-cluster, right? So this might mean you have on-prem and cloud, you might have multiple clouds, you might have just multiple clusters in a single cloud. And there's various sort of, gateways between these or networking implementations. Does OPA live in this sort of multi-cluster management when it comes to policy at all?
Yeah. I mean, I actually think this is a really good use case for OPA.
Okay.
Because I think when you get to a certain scale, like multi-cluster sometimes means we've got the US and the EU and the Asia Pacific cluster, and then that's it. But sometimes multi-cluster means we have, this entire platform over here, which is managed by this department, and this entire platform over there, which is managed by an entirely different department. They're kind of adversarial to an extent, but they work for the same company. So like multi-cluster, I suppose, is a very broad definition of like sort of infrastructure sprawl. And I think particularly in an enterprise, size business, this is quite a common scenario where the sprawl level is quite high, and like multi-cluster is actually multi-platform and like multi-team,
Cloud,
multi-division, and so on. And I think where OPA, this is actually a really good environment for OPA to run, because what you can do, I think, can be really powerful about OPA is actually giving you a way to it's around standardization. So, applications running over here might be in these languages or tend to be using these frameworks, and applications running over there are working in a slightly different way. But as a security team, or a kind of wider scope, a platform team with a wider scope to the whole estate, you might be interested in making sure that policies are consistent and consistently enforced across a very large area. And like I said, they could be quite different in lots of different ways in different areas. And I think OPA is great in that case, because you can, if you want to make changes to the policy running in lots of different places, you can centrally manage the policy and have OPAs running in different, potentially very different environments, still referring to a single source of truth for your policy distribution. Now, we have good APIs within OPA to reload policy bundles, bring in new data sets, and load them across potentially thousands or hundreds of thousands even of OPA instances. And I think that, combined with the standardized auditing functionality to gather all of those decisions that are being made in different environments together, and being able to audit that data, that decision data, and distribute new policy out of band from the other deployment mechanisms which are changing the state in these environments. I think that is what is really powerful about OPA in the multi-cluster, multi-platform use case, is that the auditors don't care about platform by platform or cluster by cluster, like they care about the business and where the customer data is and so on. And when you're trying to respond to the problems set by audit requirements, that standardization, or having a tool to standardize that functionality, I think is really important and very valuable. And I think that's where OPA fits in.
Yeah, so, and the one use case that comes to mind, right, especially multi-cluster, and you gave the example of sort of US and EU, right? GDPR comes up a lot. Are there ways to sort of realize, policies or enforcement for something like that? If maybe you're making a call to store some data, but you want to make sure it's of a certain type, or it can't be, there's some limit on how long it gets stored. Like, where does OPA fit there in that? There's just one example that came to
mind. Yeah. So I suppose like there are sort of two parts to that. Like, it depends how you, like, OPA can't magically find out if you're sending data to a different part of the world. But at the same time, like, OPA is well equipped and offers you the tools that you would need to implement such policy. So if you have for sake of simplicity, a cluster which stores data and runs applications in the States, you have a cluster which stores data and runs applications in the EU. You have two OPA instances running in those two clusters, just again for the sake of simplicity. You can have those OPA instances labeled such that they load differing policy versions.
Right.
So you can still define standard policy in one place, but the policy which is realized and enforced in those two different locations is controlled by the environment that instance is running in. And you can, again, based on labels, describe the instance's environment. And then I suppose as to like what that policy might look like, it might be that you have a storage service which has a host name which is something like US or uswest.example.com, storage.uswest.example.com, and you might write policy that that only applies to services in the EU, that if they attempt to connect to within the service mesh use case, maybe they're trying to call out to a US host name, they'd be like, oh no. Or if it's a post request, but not you can get data from the US, but you can't post data to the US or something. Like that's how you might enforce that kind of policy. at least in an HTTP use case. So yeah, I don't know. Hopefully that answers the question.
Yeah.
I think that's kind of how I think about
absolutely.
And I think that strikes a follow-up question for me, right? So in that example, you laid out a cluster in US, cluster in Europe. Is there a way, like if as an admin I have like a GitOps pipeline or something that is deploying new clusters, can there be a way that OPA becomes a part of that deployment and then it automatically pulls things based on labels? So like something gets triggered, a new cluster is deployed, somehow OPA is deployed on it, and then it uses its EU tag and pulls down the policies. All of this possible? Like, is all of this automated?
Yeah, so we have the concept of a discovery. The feature is called discovery in OPA, which allows you, as you described, to label new instances and have instances. We load a particular discovery configuration, and then discovery configuration based on some Rego, which runs when the instance starts, will define what policy is eventually loaded. So and that as long as the policy bundle server is network reachable from the instance which is deployed, then it can pull down and load, ready for evaluation, the policy that it needs. So you could have the deployment of OPA of an OPA instance, just again for the sake of simplicity, but it could be a sidecar or whatever OPA service in a given cluster could actually be very minimal. It could be like, okay, I need to run OPA and I need it to be labeled as this is an EU deployment of OPA in one of our EU clusters, and then it can be that once it knows, all the OPA instance knows is like, I'm an OPA instance and I'm running in the EU and this is where I go to get my policy. And then once it knows that information, it can then go and fetch the policies that are available or expected to be loaded for an instance, meeting those specifications at that time. So yeah, it's not like in order to update policy versions and things, I think it's interesting because it's kind of like it is slightly different from the Kubernetes sort of default mindset. It's like I need to make any update involves an update to the Kubernetes API, but I actually think I'd like people to consider whether that is the correct way to think about updating of policies, and especially when you think about it from this like higher level, multi-cluster, multi-platform use cases. Like, well, actually, we might want to roll out some new policy. And gather policy separately, especially if people are running hundreds of clusters. It's like, okay, so I've got to update hundreds of clusters in order to update policy in hundreds of clusters. And it's kind of like, that doesn't necessarily match what I'd like. Like, yeah, you still want to, release policy in a reliable way that you can be confident about once it goes out that it works. But like, we have lots of tools for that too. Like, you can write Rego tests. You can deploy policy to a separate environment, or still run things through dev stage prod if you do that kind of thing. So I'm not necessarily like saying, oh, this is always going to work. Test in prod, you'll be fine. But like, just I think thinking about policy being a function which isn't necessarily always defined in the Kubernetes API for the multi-cluster use case can be quite allow you to be quite reactive and give you a lot of sort of benefits of standardization at that scale.
And one more follow-up, right? Like, I think I might have missed this in that explanation, but I just want to confirm. If I add a new policy or change an existing policy, and if I have those hundreds of clusters, I don't have to trigger anything manually. It is like if you have like a CD system, right? Continuous deployment, there's an agent running that will automatically pull these new policies and enforce them.
Yes. So the way that would work is you don't need to, like, crucially, as I said, you don't need to go around and update all of those OPA deployments. You can have so it's kind of just based on HTTP, and if the ETAG, the header is set different, it will load a new policy version. So like that's typically how it's communicated. It's like, this is where you should load your policy from. It'll download it and load it one time, and it will know what the ETAG on that policy was set as. And like, it's like, oh, if you're thinking like, oh, now I've got to like make sure that my server is setting the headers and stuff. Well, yeah, you do, but also like common object stores will do this for you. So like, if you just push to a new path within object storage, the ETag header will be updated for you. So like it could be that you just bundle up your policy and push it to S3 and you get this functionality for free.
Gotcha.
And you can configure how OPA polls. Like you can make it poll once a second if you want. And the eventual consistency model, I think, generally works pretty well.
Yeah.
There are various ways about bringing in data and policy updates more quickly. Data updates more quickly, but for policy, I think like that kind of resolution is usually fine for people.
Yeah, and I imagine there's also other ways you could do this with like GitOps tools like Argo, maybe, since it's, policy is driven at the, Rega language, right? Is that a fair statement to say as well? That there's ways to do
this would be around rolling out updates to your policy using a sort of standard CI/CD tool.
Yeah.
Okay. Yeah, so I guess in that case, it would be like, oh, well, there's a Git repo and it contains all of the policy, or it contains the policy. The CI/CD tool might pick up that and it would run some tests against it. It could run some unit tests. It could also spin up an OPA instance and load in that policy and run some end-to-end tests, making some example HTTP requests, for example, do all sorts of things. And then it could be like, okay, I'm going to, push this policy bundle to a pre-prod or some kind of canary setup and like monitor existing deployment of open as like, okay, they haven't all, they're not all erroring. Like in the status of OPA, you can the like health check, you can check whether the OPA instance has successfully loaded a policy bundle, and then you can monitor you could do something like, make sure that all of a sudden not everything is being denied, or whatever check you needed, and then you could proceed and do like a multi-stage rollout, codified in your pipeline in some way. I don't know. Was that the question, or have I kind of missed the point?
Absolutely was the question. Yeah.
Okay.
I just think we've talked a lot about that on the show too. So it might be something.
That's how I would imagine it. Like you can go as deep as you want, I suppose, on like the multi-stage rollout of different policy versions. But at a minimum, you could have Argo run your policy unit tests and deploy it to a pre-prod environment, and then you could do some manual testing, and then you could continue or whatever. But as long as it can update some HTTP server that serves policy bundles in the end, then you're fine.
Right. All right, makes sense. Well, I know we're coming sort of to the end of our time here, so I want to make sure you have a chance to. I know we didn't get to talk about Terraform or like validating, Terraform plans or anything like that, but we'll make sure to put all these links in here. But if there's anywhere, someone listening might be interested in learning, getting started, learning more, how do they find you? This would be the time to give your shout outs.
Yeah, sure. So I'm Charlie Egan 3 most places. So if anybody wants to reach out to me, they can do that. I have charlieegan3.com.
Nice.
I have a very predictable Styra email, but I'm pretty easy to find myself. But yeah, just to just on the Terraform thing, the tool is called ConfTest. We have a community project in the OPA ecosystem that's quite good for that particular use case, but I'll provide you guys some links of different bits and bobs. But yeah, like at the very beginning, I said that I was interested in making OPA easy to use and helping people who are learning. I think OPA's really fun, and I really enjoy writing Rego, and that's why I'm here. But I'm keen to help other people go on that journey. So yeah, I mean, just to list a few things that I think people would be really good for people to start with. It's obvious that there's the OPA docs, but if you're interested in just getting a quick start with the language, I've also worked on this Rego cheat sheet recently, which is a kind of one pager. There's even a PDF that you can print out if you wanted to sort of highlight some common or sort of key contact points with the Rego language. I think the language is often the beginning of learning OPA, and I hope that this is a useful tool. For people who don't know about it, there's a playground, an online interactive playground at play.openpolicyagent.org. I'll send the link for that too. This is a way that you can provide information in the way that OPA operates, where you have some input information, some data which has been loaded in, prior to the policy evaluation time and your policy code, and you can click evaluate in your browser, and you don't need to worry about running containers or installing binaries or anything like that. And I think, I still use it a lot. So, and I don't think I use it less than I used to. I think I probably use it more. So I think it is great for beginners and anybody playing around with OPA and Rego and trying to get their head around things that work. It's also a really good way to ask for help, because there's a publish link. You can share some policy, some data, some input, and try and see why with a colleague or in the OPA Slack, which is where we do a lot of community support. In the playground, there's also the linting output. So in the last year, my colleague Anders and I have been working on a new project called Regal, which is a linter for the Rego language, which has a large array of different recommendations to Rego code. The output from the linter is displayed in the playground, but you can run the linter on your laptop. You can run it in GitHub Actions on some. If you have a Rego policy code base, you could run it too. So yeah, I'll share a link to that too. We're excited to have people try that and give us feedback. But it's we're very happy with where it is at the moment. Recently, we've added support for the linter in VS Code as well. So if you're a VS Code user, that would be a great thing to check out.
Okay.
And finally, the OPA errors, we've been working on this OPA errors section of our doc site, which I'll share a link to as well. It's a kind of common errors that you might encounter when working particularly with Rego. I think because of the Rego works in a slightly different way from what people are often used to and familiar with, some of the errors, can use a little bit of extra information to get to the bottom of what's wrong. So we've got that too. And I'll share the links for the Slacks and
awesome resources. Yeah, for sure.
Cool. Yeah, that's great. And remember, Charlie Egan 3, not the first or second one.
The
third one.
Yeah.
Does it have something to do with British royalty, or just that's the username you got?
No, when I was very young, my lucky number was 3. So and Charlie Egan wasn't. I think it was when I signed up for a Gmail account way back. So I was like, I'll have Charlie Egan and my lucky number, and I stuck.
Even better coincidence, right? Charlie, thank you for coming on Kubernetes Bytes. I learned a lot. I think there's a lot more people could learn as well. So appreciate it once again, and it's been a pleasure.
Great stuff. Thanks both.
Okay, Bhavin, that was, I know, quite a learning experience for me, having known nothing about OPA before going into this conversation. But that's the beauty, I guess, of having a podcast and learning in public. So, yeah, I'd be interested in hearing what your takeaways were.
Yeah, and Ryan, I was in the same boat, right? Like, I had done some research. I always liked their Viking-based stickers and things like that, and the logos that they have, but apart from knowing that they help you with admission control, I didn't really know what everything, like what are the different use cases for OPA. So I was glad that we got Charlie on.
Yeah, for sure.
Whose day job is to talk to people about what OPA is and how it can help.
And he did a great job.
Yeah. So again, this was another experience where we learned a lot from the actual episode. We do try to do our research, right? But even in research, when we read text, sometimes it doesn't really add up to what you can get from a person who deals with something on a day-to-day basis.
Absolutely, yeah.
Yeah. So the discussion around admission control and gatekeeper and how they can add to existing RBAC that Kubernetes offers out of the box, I think that was really helpful. I like the Rego integration so that you don't have to rely on after your apps are deployed. You can include it as part of your application as well. So when it gets deployed, it has some of those admission control things, or it has some of those rules where it doesn't have to take in requests from a specific part, or the different microservice that might be part of your application. I think that was really helpful. And I'll just end with saying auditing, as we all know, is super important. You don't want, first of all, you don't want anybody unauthorized to access your clusters and resources. But then if somebody tried to do that, you need a solution that you can go back and look at historical data and how it can help you improve your security faster. So I think those were important takeaways for me.
Yeah, for sure. I came away from this conversation really understanding more about how flexible the tool is, right? As a framework, right? So OPA is not just something you can use in the Kubernetes use case with admission control, but even within Kubernetes, right? I was kind of looking while we were talking, and you can do some basic stuff like, everything that gets deployed and goes through these policy checks, must contain this label or have
a specific host name.
Yeah, that kind of thing. Right. There's so many things you can do, and kind of back and related to a lot of the IDP stuff we've been doing. You could easily see how an IDP could kind of build this into, their golden path, where it's like a lot of this stuff kind of just happens as you deploy, and let alone the sort of infrastructure and tooling beyond OPA. So that was, I think, enlightening, and the fact that you can use it with CloudFormation and Terraform and Envoy and all these things, like being able to produce a Terraform plan and send it through sort of OPA to do some policy checks on, hey, is this plan compliant before I go ahead and send it,
Nice. No, agreed, right? And again, to just add to your statement, like the multi-cluster management, how OPA can have that single store where you have all your policies, and then each new cluster or each new OPA discovery agent that comes online can pull down those policies. I think that's super important. Like, things have to be automated to that extent that it doesn't become a chore. And like security by default, I think is a good place to be in. So OPA definitely is a cool project that I would like to learn more about, and hopefully our audience.
For sure, right? Because I feel like OPA is one of those tools that you find as a solution to an issue, right? Where it's like, maybe you're building a platform, and then all of a sudden you have the need for these other compliance related or sort of policies, and you're like, oh, OPA might be the tool for that. It's hard for me to think of, like, I'll think from OPA from day one. So that's maybe that's a challenge for just me being not familiar with the tool, which is probably the reality.
Experts, right?
Yeah. Cool. Well, hopefully you listeners have also got something out of what OPA is. And if you aren't familiar and you learned something, then great. We accomplished our goal for today. Just as a reminder, again, May 22nd, use the code Kubernetes Bytes for a 10% discount off your registration fee for the Kubernetes Community Days in New York City.
And this time we came prepared. Like, May 22nd is actually a Wednesday, dude.
Yeah, I didn't even say it this time. It's a Wednesday. So middle of the week should give you time to get there and take off. Or if you're already in the city, then even better. But please use the code Kubernetes Bytes. I don't think it needs to be in all caps, although that's how we have it here. But if it doesn't work the first time and you have it in all lowercase, try it in all caps. We'll see. I'm not sure that's a real thing, but anything else, Bob, before we wrap it up here?
No, I think we are ready to wrap this one up.
All right. Well, that brings us to the end of today's episode. I'm Ryan.
I'm Bhavin.
And thanks for listening to another episode of Kubernetes Bytes. Thank you for listening to the Kubernetes Bytes podcast.